integrate x squared plus 5 times ln x. Okay, so immediate reactions, I'm seeing a product. That makes me think integration by parts. And if we're going to do integration by parts, okay, which remember looks like u dv gets switched for u v minus v du, we need to identify one of our functions, one part of our integrand as a u, and the remaining part hopefully is a derivative of something that we can recognize. That becomes our dv. So what have we got? X squared plus 5 ln x. So it really seems separated into this polynomial part and this natural logarithm. Now, in general, logarithms are probably the last thing you should take for your dv. Right, so maybe we should experiment with the x squared plus 5. On the other hand, using integration by parts, we have learned what the antiderivative of ln x is, so maybe this should be our dv. Okay, and then our v would be, what did we learn it was? X ln x minus x. Maybe that's the way to go. Okay, it's trial and error. Okay, there's no definite, you have to do it this way, you have to do it that way. But as I say, in general, logarithms are the thing I tend to avoid. There's the last thing I would expect to be my dv when I'm doing my integration by parts. So let's try the polynomial, shall we? Okay. And so ln will be my u. And so du by dx is going to be 1 over x, and we can rewrite that and say that du is 1 over x dx. And I know how to anti-differentiate polynomials. Polynomials are really nice. Increase the degree by 1, divide by the new degree. Okay? And for integration by parts, when you're doing this part, you don't need any constants. Okay? Don't worry about it. So just take the one that doesn't require a constant. Okay, so that's our plan. Now we make the switch. So we do u times v. We just worked out what v is. Minus, now we do v du. Okay, I'm going to move this over to the other side, or to the next page, I guess, and clean it up a little bit. Not much to do here unless I wanted to make it 15x over 3 just to combine them. Maybe I'll do that in a moment. Okay. But definitely I can see, oh, this 1 over x, there are x's inside the x cubed, and the x, I'm going to take a factor of x out of the polynomial. So we'll get x squared over 3 plus 5, 1 over x dx, and now those cancel out. And so x cubed plus 15x, just to combine it all into one fraction. And then minus, well, we just need to integrate another polynomial, but we know how to do that. Increase the degree by 1, divide by the new degree. Okay. So we'll get ln x. I'm also just sort of playing around with the first part here. Increase the degree by 1, so x cubed divide by the new degree. Now we already had a divide by 3, so now it becomes divide by 9. Okay, and then 5x here. We don't forget our plus c. You could leave it like that. I'd probably expand the subtraction. So distribute the minus sign. That's a little nicer. Less brackets lying around. And there we go. Integration by parts. We chose our polynomial, left our logarithm alone, and we had this nice 1 over x and x canceling out, which was really good. Really good for us. So there we go.